Hello everybody, welcome to Embrace the Red. Today we'll talk about SQL injections. This is very good for beginners. So if you have never heard about SQL injections, this is going to be perfect for you. Let's get started. What is SQL or SQL, how many people call it? It stands for Structured Query Language, and it basically is how you talk to a database system. MySQL or Postgres, or in this case, I love these examples that I'm going to show with Microsoft SQL Server. At a higher level, there's DDL, data definition language, and that sort of deals with the creation, the modification of objects in the database, like, a database itself, a table in the database that contains information. So it's about the design of how a database looks like. And the second part is the data modification language, the DML, which is about selection, which means querying data, inserting data, updating data, or deleting data. And to give you an example of how this looks like, here you have Azure Data Studio, which is a client that can communicate to a database system you can connect. So I connected to the database here, and I'm running an SQL query called select hello world. And select basically is a statement. It's sent to the database server, and select just means query something or give me something back. It's like printing in this case. So the data you get back is referred to as a result set, and it comes back in a table format. So it has rows and columns. Now let's look at this more with a little bit more data. So let's say we have a table called messages, and we select, meaning we query the ID, the subject, and the message content from this messages table. So we send this to the database, and we get back, now you see a table of all the messages, and we selected these three columns, ID, subject, and message. And that's the data we get back. Very cool. There's a lot of advanced features. There's tons of options on how to select, to optimize, to kind of aggregate, to sort, to order. But one really common feature in applications is that you want to filter data, right? And that you can do with the var clause, where you select from the messages table in this case, and then we have a var, the subject, and in this case we use a like operator, which sort of is like a contains. In this scenario, we ask for anything that contains the word how, and the percentage signs are a special indicator here, which means just any character before or after matches. So it's like asterisk. Often you see an asterisk depending on the database system. In this case, it's a percentage sign in Microsoft SQL Server. So we send this to the database, and what we get back, ta-da, we get back filtered information. So not all the rows from before, but we just get back those that contain a subject with the word how in them. And you can see there's these two rows contain the word how. Excellent. Often you can query other information about the database system, not just the tables or the data in it, but you can also get information about the current user logged in. Add version would return the version. So you send this to the database, and we get back the letters SA, which in this database system means system administrator, and we get back the version number, and we see it's Microsoft SQL Server 2022. Very cool. And the last thing I want to talk about, which becomes very interesting from SQL injection point of view, is this concept of union, which means basically concatenate two result sets into one table. So the first part here, again, as we did before, we select from the messages table. Very, very straightforward, right? We get back all the messages, but then we do a union, which means we add on an additional table. In this case, it's just a table with one row, right? We select 0 as identifier, hello as the subject, and world as the message. And now we send this to the database, ta-da, and we get back now an additional row, right, that we just created out of thin air, so to speak, and we append, in this case, because we gave it the ID 0, it's going to show up actually even as the first entry in the result set. So union, very important to understand. It helps concatenate multiple queries into one single result set. How does this now apply in a SQL injection attack? Very common is that you have a web application, but it is definitely not limited to a web application. That's important to understand. But the scenario we want to walk through here is a web application. So we have Bobby using a system, a web server. It's called the mail server, and the backend, it has a production database where it stores all the mails. And Bobby sends an HTTP request. searching for emails, and he's querying for the keyword Alice. So the web server gets that request, it translates the HTTP request into an SQL query, as we saw before, right? The web server now speaks SQL, gets the data, runs the SQL query, as similar as you saw just before, sends back the data, and Bobby now has the data retrieve those 2 rows from the database. Very, very straightforward. Another way to look at it is, so we have the web server translating it to a database query, and then we have sort of this HTTP request with the keyword. And the way you can think about it, right, there's the server has this like statement, and it's just going to replace this string in the like statement with something else, and then you get the corresponding data. How does SQL injection now work? So we have the same system, the mail server, but now we have Mallory that is malicious and wants to exploit this system and get different data or more data back. So Mallory does a query, but it's not just the query for Alice. You see now there's a single quote and then the union, which we learned earlier, right? Union concatenating multiple pieces of information. In this case, just union, as we saw before, like system user and version, just 2 database internal pieces of information. And Mallory sends that in, and the web server now translates that into an SQL query. But because there was a SQL injection, which means the single quote is problematic, we'll talk about this in a lot of detail. So because of that happening, the database query now looks different. It has basically two queries, right? It queries for Alice, but then it also runs the second query for system user and version. And all of that is now sent back to the web server and then sent back as a result set in the web. You would see this probably in a UI, but the data that comes back basically is the records for Alice, plus you can see select one as the first entry we get back now, this internal information about what's the database user and what's the version of the database. And so this is how a typical SQL exploit looks like. And in more advanced scenarios, right, you would start querying data, querying other tables, and you kind of exfiltrate all of that information. At a high level, what is possible, as you can see, there's data exfiltration from the database. You can build entire botnets, and we'll talk about that a little bit more, where you get code execution on the back end. You have ransomware, right? You could encrypt the data because you can also run like update statements, for instance, or deletion of data. And similar to what I talked with botnets, there's also remote code execution that some database system have the capability to run commands, and then the attacker can directly execute commands on the backend. Now, looking at this again from this template kind of point of view, again, web server, since translates the web request into an SQL query. And now with the attacker, right, the attacker is not putting just a string, they put this whole union statement with a single quote in the beginning. But what happens here is the attacker inserts a quote as part of the payload, the untrusted input, which closes the initial like statement. So that like statement is now closed, it's complete. And then they add on the union statement, which is the second statement that is being run. And then in the very end, this is the key point, there's this dash dash, which is a comment, because there's still this one single quote in the end that would be there and that shouldn't be there. And so that's how they kind of comment, the attacker can comment that piece of information out. Let's take a look at how this actually looks in code. So this is a piece of code that has exactly this SQL injection. It's written in C# talking to a Microsoft SQL Server database. I don't want to focus too much on the statements around. I want to highlight and talk about the key components. So we get in the query string. So this is the query, like Alice, what we saw earlier in the example. And then the code is building a SQL statement. You can see this concatenation happening. So the untrusted data is concatenated into the query. So if the untrusted data contains a single quote, then the single quote you see from the like statement will be closed, and then the attacker can append their own statement after that. Here's a web server, Area 51. There's an API called search with a query parameter, and we try out and show how the system works. So we enter query equals Alice, and the system returns in a JSON payload, which Firefox in this case nicely formats. And it just returns all the records that contain the word Alice. Perfect. So next we tried a single quote, and that usually gives the highest level of success as it's most commonly used as a delimiter in SQL dialects. And when you get something back like this, you see an error message like this, which states unclose quotation mark. If you ever see this, you know there's a SQL injection. So now let's see what we can do next. So let's again enter Alice. So we see the data that comes back, the result set has 3 columns: ID, subject, message. So a typical way to go about it is we do the quote to close the where clause. Then we do the union, we do a select, and since we don't exactly know, although in this case we can probably guess, the column data types usually start out with null as sort of this wildcard to figure out how many columns there are. Let's say we assume there would be, let's say, 4 columns. And we do the dash dash to close out the comment. So if you do a select of 4 nulls, right, we see if we guess the schema right, if there's 4 columns, it should give an error. Yeah. So it doesn't match the number. So it says all queries combined using a union operator must have an equal number of expressions in the target list. So we have the expressions don't match, because pretty positive it would be 3. Exactly. So it's 3 columns. So technically in the very bottom we should see, yeah, here you see there's an error message, which is our null now. So we already know that the first data type is an integer, int64 actually. So we know that this has to be a number, which is kind of obvious because it's the ID. And you can see here the verb server already leaks more information to where it is actually stored, right? So it's a source code location. And then we have the next 2 columns, a subject and message. So those are definitely strings. So it should be pretty easy. So if you do hello, and here we enter world, we should actually now be able to add a row to the result set. Here we go. Do you see that? So now we actually start seeing how injection works. So you can modify the data that comes back. And the very kind of cool next thing to do is you kind of want to see which user the system is running under. So system user, as well as the version of the server, of the database system. And here we go. See, you get the subject back as now showing us the machine name and the username. It's pretty cool. And then you also get to see the database version, in this case, a SQL Server 2022. Next, what we want to do is we would like to query, of course, information from another table or see what tables are available in the system. You can query something called the table catalog, which is like the database name and the table name, of course, from, and this is sort of every database system has this because it's an ANSI standard, information underscore schema dot tables. So this now will give us back all the names of the tables in this database in this JSON result. And there's a table users. So now let's look at all the columns of the users table. So in order to do that, we're gonna say column name, and we want to add the first being the table name, column name, from information schema columns, where the table name equals the users, right? And now we get back for the users table, every column the system has. And we can see there's a password. That sounds interesting. And the username. So let's query email and password. So now we know the table is called users. So we're gonna do the ID, we just pick 0, and we're gonna return the email, and we're gonna return the password of all the users. And okay, obviously, my bad. So in this case, we need to do from users because now we know the table name is called users. And here we go. Now we extracted all the passwords and emails from that table. Pretty cool. One more thing that we haven't talked about yet is there's more powerful statements, and one of them I want to highlight in a database system is execute, store procedures. Like you can write little programs in the database that run like functions or run code or logic inside the database, and they can be executed with the exec or execute statement. The mitigations. What are some of the mitigations? Parameterized queries. That is kind of a key point that whenever you can use, you should use parameterized queries, because then the database server is taking care of all of these potential problems. Whenever a developer concatenates strings, all alarms should go off and you need to start reviewing that code really detailed. There are systems like an entity framework that can do a lot of that automatically. Like you will have objects rather than writing your own SQL. That can be very helpful. And if you really need to concatenate strings, right, it's always about the proper input encoding, where you would escape characters correctly. For instance, with the string literals that we saw, the single quotes, it is very important to kind of, in Microsoft SQL Server, you would double quote, like you say single quote to escape it. But parameterize all queries. And especially SQL literals cannot be parameterized typically. You see, for instance, here code that would create a login. That username needs to be in square brackets because it is a SQL identifier. It's not like a string. And in order to correctly escape a SQL identifier, you need to actually encode the closing bracket twice. So this is very important. This is often missed in code reviews and doing bug bounties, that you should also test for this scenario. We have the closing bracket that is not escaped. And then you get SQL injection as we saw before, not with the single quote, but with the closing bracket. Injections can also occur in comments, which, you know, some developers might actually place the untrusted user input into a comment, and then an attacker can use different characters to break out of the comment. For instance, with in this first line, an attacker inputting asterisk slash forward slash would break out of the comment, and then they could run their own statement after that. Similar with a dash dash, which is a single line comment, if the attacker can inject the carriage return line feed, a new line, they can again execute code, but data becomes code. So this is always the problem, but data becomes code. Okay, so that was sort of this brief introduction for SQL injection. I hope it was insightful. I will have another video up shortly that talks about more advanced scenarios, in particular SQL injection by truncation, which is not very well known. So check back soon. Subscribe to the channel if you like it. Leave some comments, and have a